Hey guys, it's Tuesday Talks for kind of February 25th, 2020, something like that. It's Friday, but this week was a Monday and a Wednesday and a Friday all mixed in one, so forgive me for the tardiness on my post. But this last Tuesday Talks of the Unit 5 will walk you through some more advanced options of adding and subtracting rational polynomials, and multiplying and dividing, actually. This first one has addition. Remember, with addition, we always need a common denominator. So the important thing for you to do is to recognize, of course, they don't look like they're in common at all, but the factored versions will give us a better idea of what they do have in common. So I factored the left one to x plus 3 and x plus 3, and the right one was x plus 3, x minus 3. Remember the difference of squares. Now they do share in common an x plus 3, so those they have to start in common, but they do need to have both sides in common. So since this one has an x minus 3, we're going to multiply this left one by x minus 3, but what you do to the bottom, you have to do to the top. Now the right side, he has the x plus 3 the left side has, but he doesn't have two of them. So we're going to multiply this right side by x plus 3. Now that means our common denominator is x plus 3 times x plus 3 times x minus 3. I'm actually going to only write that once. This plus sign right here, I'm going to drop down into the middle there and treat them separately just to save time in writing the x plus 3's twice, or the common denominators twice, I'm sorry. All right, so for this top side, when I said I need to multiply by x minus 3, that means you actually need to distribute all those four pieces out. So we'd have x squared minus 2x, which we'll check that math up there if that doesn't make sense, minus 3. On the right side, we have the same issue. We have to multiply all four terms. So we have x squared minus x minus 12. To get our final answer, we need to go ahead and simplify everything in the top. So I have x squared and x squared together. That makes 2x squared. And negative 2x and negative x added makes negative 3x. And negative 3 and negative 12 added makes negative 15. All over x plus 3 times x plus 3 times x minus 3. Now I mentioned before that you want to check if you can ever factor anything. This guy right here actually is going to be our final answer. What you'd be looking for is if your numerator would ever have an option of having x plus 3 or x minus 3 in the top, but I've tried factoring it with those as factors and it doesn't work out. So for that one, we are done. That was addition. Now I move to subtraction. Not much changes. There isn't much difference, if you will. For subtracting, you just have to have the common denominator and watch your negative sign as you apply it. So if I factor this bottom right side, I get x squared, x and x and then minus 7 and plus 3 should do it. Could factor the numerator as well, but for right now, let's just focus on our denominator. Notice this left side says, well, that's not fair. You have an x plus 3. He's going to want one as well. So when I multiply this out, again, remember that parenthesis is there, I'd have x squared plus 5x plus 6 minus, again, that's all over x plus 3 and x minus 7 now, minus x squared plus 4x plus 13. And then x plus 3 and x minus 7 still his common denominator. Now the only tricky part is being sure that you don't forget to use your subtraction sign like all the way through. So x squared take away x squared is gone. 5x take away 4x is 1x. 6 take away 13 is negative 7 all over x plus 3 times x minus 7. But wait, this x minus 7, here we'd have a whole. If we go back to our last lesson, we would actually cancel those and leave it as 1 over x plus 3. And that would be our fully simplified version. Now for multiplication. I actually find multiplication and division to be easier as long as you can factor well. So let's take a look at this. Let's factor both the top and the bottom. So up here I'll have x, well, I can do y, I guess, same difference, y plus 5 and y plus 5. Down here we have the difference of squares, y plus 3 and y minus 3. Over here we've got a y in common, so I'll pull out y times y plus 3. Now, we can just multiply across and leave everything sitting by each other on the top and the bottom, but just don't distribute them through. That's not helpful. But we can also cancel if something's the same up top as it is in the bottom anywhere. So I can cancel out this y plus 3, and this y plus 3, and this y plus 5, and this y plus 5. So my final answer will be y times y plus 5 up top, again that y and this y plus 5, over only y minus 3 in the bottom. And there you have it. Once you factor and cancel, multiplication's so much easier. You don't have to worry about negative signs. You don't have to distribute. Super easy. All right, division. Division is really just multiplication with a flipped fraction. Maybe you've heard of dividing as multiplying by the reciprocal, and that's the case. When you see this division sign, you can turn it into a multiply as long as you flip-flop these two. So I'm going to factor as well as do that flip-flop on the right side when I get there. All right, this top part, he is going to be y plus 6 times y minus 6 over, factor the bottom to be y, 4 and 4, minus 4 and y minus 4. Now I'm going to say times, but I'm going to flip these. So to factor this bottom, it'll be at the top now. I have y minus 4 times y plus 3. And the denominator will be this top guy. He will be taking a 3 out front. So you'd have y minus 6. Now we're back to the last slide where we just do multiplication, and that simply means we cross-cancel anything that's in the top with the bottom. So this y minus 6 can cancel this y minus 6. This y minus 4 can cancel this y minus 4. And I think we should be good. Some might say, gosh, can I cancel this 3 and this 3? But remember, he's a unit. This y plus 3 sticks together. So my top would be y plus 6 times y plus 3 all over the denominator of y minus 4 times 3. And I'm going to stick that 3 out front here because I prefer to have my coefficient out front. And this is your final answer. That's it. So that's all for today, guys. Again, you should be able to add, subtract, multiply, and divide rational polynomials. Hope that made sense. And that's all. Berkland out.